4.5 is solving rational equations. When we talk about rational equations, realize a rational equation contains at least one rational expression. We've talked about rational expressions just being fractions, right? Fractions with variables in them. If you look at the equations on the back side of the paper that we'll eventually get to, they are equations with fractions in them, okay? When we talk about solving these rational equations, the easiest suggestion is going to be, I'm going to say, get rid of your fractions. So we're going to talk about knowing how to clear our fractions out, and we're going to do that by using the common denominator. So similar to yesterday, we're still going to be finding a common denominator, but we're going to be using it to multiply by and get rid of our denominators. Because once you guys have an equation, if it doesn't have fractions in it, I have faith that you guys can solve it. And so our job is going to be to get rid of those fractions. And then we are also going to want to be on the lookout for extraneous solutions. Extraneous solutions are those solutions that you get as what appear to be legitimate answers. We do the work, they solve, they come out as an answer, but when you go back and check them in the original problem, they don't work, okay? The big situation, you guys know how we've had the restrictions on the variables, and we've had places where we can't let the denominator equal 0. Those are going to be the ones we have to watch out for, is if you get an answer that would then make the denominator equal to 0. Okay, so we will be checking solutions, but I'll make that easy on us. Okay, so we're going to start here with a couple of basic problems. Okay, the trickier ones are on the back, but we're going to start basic here. So find the solution to each rational equation. Be sure to check for extraneous solutions. You see the equation 2 over x plus 5 equals 4. Ideas of where to start. Ideas of how to solve here. My hint will be if it's 2 divided by x plus 5. What's an option there? It's the option of, what's the opposite of dividing by x plus 5?
By negative x.
Don't change anything up.
Oh, yeah.
Just the opposite of dividing by x plus 5 is to multiply by x plus 5, right? So that's what we're going to do here, because what we have is we have a fraction. I want to get rid of that denominator. So since it currently is dividing by x plus 5, I'm going to multiply by x plus 5. If I multiply the left side by x plus 5, guess what? We're multiplying the right side by x plus 5. I am putting it in parentheses because it's a quantity there. Now, on the left, it's x plus 5 times a fraction. How do you make x plus 5 a fraction? Put it over 1. Okay, sorry, my x plus 5 is kind of written over my a there, but I think you can see it. What happens? X plus 5 on top can cancel with x plus 5 on bottom. What remains then? 2 equals, on the right, you're just doing a simple 4 times x plus 5. How do we multiply 4 and x plus 5? We're going to distribute. So 4 times x is 4x plus 4 times 5 is
20.
Okay. Folks, that fraction is gone. You've been solving that type of equation since middle school at least, yes? If it's 4x plus 20, how do I solve? We're going to subtract 20. If we subtract 20 on one side, subtract 20 on the other side, 2 minus 20 is negative 18. On the right, I have 4x, and 20 minus 20 will cancel. How do I finish solving for x?
Divide by 4.
Yeah, if it's 4 times x, we're going to divide by 4. We divide one side by 4, we're dividing the other side by 4. As it is right now, I have negative 18 over 4. Do I get to leave that answer?
No.
No. You don't get to leave it for me for Savas. You don't even get to leave that one for me. What do you know about negative 18/4? They both divide by 2. So if 18 and 4 both divide by 2, this becomes negative 9/2. Okay. I personally would accept negative 4.5. Savas, I don't know. Read the directions. You never know with Savas, right? Read and see what they say. Now, before we try the next one, it said be sure to check for extraneous solutions. I'm not trying to make life difficult here. I'm not saying that, okay, you need to take negative 9/2, you need to plug it back into the equation. That's not what I want you doing. What I want you doing is just making sure, does this make my denominator 0? And no, what would be the problem? What would be the answer that we could not have? If x plus 5 equals 0, we know that we would have a restriction of x cannot equal negative 5. Did we get an answer of negative 5? No, so our answer should be good. Okay, that's the kind of check I'm doing. Is just, if it makes the denominator equal to 0, I need to get rid of it as an answer. But otherwise, it should be good. Okay? Let's try one more of these. Let's try B. 1 over x minus 7 equals 2. What are we going to do to solve this equation for x? Okay. If it's 1 divided by x minus 7, we're going to multiply by x minus 7. What we do on one side, we do on the other side. On the left, since we're multiplying by a fraction, I made x minus 7 a fraction by putting it over 1. Okay, what happens on the left? X minus 7 and x minus 7 cancel, leaving me with what? Just 1, yes? On the right, there's no fraction, so we're not canceling anything. 2 times x minus 7 is 2x minus 14, good. How do we solve for x?
Add 14.
Yep. It's 2x minus 14. Work to get that x by itself. And add the 14. 1 plus 14 is 15 equals 2x. And to solve for x, you're going to divide by 2. What is my final answer here? Yeah. I personally would just leave it as 15 over 2. 15 and 2 do not reduce. You tell me 7.5 or 7.5, that's great as well. Check it. Would this work? 15 halves. Does that make my denominator equal to 0? No. The answer that we could not have is x would not be able to equal 7. But that's not an issue here because we got 15 halves. Okay. When we get to the backside, I'll have some extraneous solutions, so I'll be able to, demonstrate that a little bit better. Okay, so I'll be honest, these are the very basic type of this equation. Okay, we'll get trickier on the backside. But this is a basic idea. Look for that denominator and multiply by it to get rid of everything. Okay? Now, before we move to the backside, guess what? We got to talk about a couple word problems here. Okay? And these are word problems that they're going to give us rational equations. So they're going to give us equations with fractions in them, and we're going to have to talk about how to solve them. So, Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long will it take Cheyenne to paint the wall if she were working alone? So, we know how long it takes them to paint a wall together. We know a relationship in terms of Cheyenne can paint a wall or works twice as fast as Arthur. But we want to know specific timing here. How long will it take Cheyenne to paint the wall if she's working alone. Okay, I'm going to lead you to it, and it's going to take me a moment, but there's an equation we can write. Okay, so let's start with what we know about them together. Okay, what do we know together? Together they can paint one wall in 6 hours, correct? So one wall in 6 hours. Now, what I want to do is I want to look at everything in respect to what can they get done in 1 hour. Okay? So if they can paint one whole wall in 6 hours, how much of that wall are they just painting in 1 hour?
1/6.
1/6. Okay, so they can, I'm going to say 1/6 of a wall in 1 hour. Because that's what I want to look at, is what can everyone do, what can each of my pieces do in 1 hour. Now, let's look at Arthur. What do we know about Arthur? We don't have a specific, do we? He's the slower one, right? Okay, so what I'm going to say for Arthur is that he can paint one wall, and this is where I'm going to bring in my variable. I'm going to say he can paint one wall in X hours. Okay, I have to put a variable in here somewhere, and Arthur's kind of the base, so I'm going to use Arthur as one wall in X hours. Now, how can I express that? What portion of a wall can he paint in 1 hour then?
1/X.
Okay, if he can do one wall in X hours, he can do 1X, 1/X of a wall in 1 hour. Okay? So together, they can do 1/6 of a wall in an hour. Arthur by himself, well, we don't know what his total time is, so we're just going to say he can do 1/X of a wall in an hour. Now that takes me to Cheyenne. What do we know about Cheyenne? Okay. We know Cheyenne works twice as fast. Now, if Cheyenne works twice as fast, if Arthur can do 1X of a wall in 1 hour, Cheyenne can do twice that. So if you take 1/X and multiply by 2, she can do 2/X of a wall in 1 hour. Okay? I'm going to argue those are the pieces we need. This is all about what can each group do in 1 hour. Now, I need an equation. Together they can do 1/6 of a wall in an hour. Individually, Arthur can do 1/X, Cheyenne can do 2/X. Do you see the equation I can set up?
Yeah.
Think about it. Okay, we have together, and we have Arthur, and we have Cheyenne. What Arthur can do in an hour, plus what Cheyenne can do in an hour, should equal what they can do together in an hour. Does that sound logical? So the idea that if Arthur can paint 1/X of a wall in an hour, plus Cheyenne can paint 2/X of a wall in an hour, and then that's supposed to equal the fact that they can paint together 1/6 of a wall in an hour. Okay? From here, it's how do we solve the equation?
Multiply by X.
Multiply by what?
X.
And?
1.
No. 6. Why are we multiplying by x and 6? Those are in my denominators. We want them gone, right? So we want to multiply away anything that's in my denominator. Basically, it's my least common denominator. So we're going to multiply both sides of this fraction by, or this equation by 6x. Okay? Now, how well are you guys going to see this? I think I'm going to write it out just to be safe here. So this 6x on the left side, what's it have to do? It's going to have to multiply by both pieces, correct? Okay, so what is 6 over x times 1 over x? 6 over x as a fraction is 6x over 1, right? What is that when you multiply that?
6.
X's cancel and you have 6. Plus, now I'm doing 6x times 2 over x. So what about 6x times 2 over x? X's cancel, and what do we have?
That's more.
6 times 2 is 12. Now, on the right, it's just 1 over 6 times 6x, which is 6 over 1. What cancels? 6's cancel, leaving me with x. What you got?
We had the 6 and 12.
Yeah, 6 plus 12 is
18.
18. So x equals 18. Now, what do we know here? What is x?
Arthur's home.
Okay, so we know based on that Arthur, how long is it going to take him to paint a wall?
18 hours.
18 hours. Now, what about Cheyenne?
9 hours.
9 hours? Because she's painting twice as fast. If she's painting twice as fast, she's going to complete that wall in half the time, right? So that means that Cheyenne will complete her wall in 9 hours. Now, what was the answer to this question? How long will it take Cheyenne to paint the wall if she were working alone? And it will take her 9 hours. Now notice, if either of them are working on their own, it's still going to take them longer than that 6 hours if they're working together, isn't it? Okay? Even though Cheyenne's faster than Arthur, it's still going to take her longer if she doesn't have Arthur's help. Okay, questions on that one? Do we somewhat understand what's going on there? Okay, that's good. First hour I kind of botched the explanation, and it was, I don't know. My brain was not in the right spot for that problem for whatever reason, but let's try B. Because if you're kind of understanding A, B will help bring it together. If you're kind of confused on A, maybe B will help bring it together. Okay. It takes 12 hours to fill a pool with 2 pipes, where the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? See, I'm visualizing a big backyard pool, and I'm thinking, man, 12 hours to fill a pool seems like not very long. But 2 hoses, so. Okay, shall we start similar to how we started last time? What do we know first?
Together, 12 hours.
Okay. Together, it is, they can fill 1 pool in 12 hours, yes? What does that mean that can be done in 1 hour?
1/12 of the pool.
Okay, so that means 1/12 of a pool can be filled in 1 hour. Okay, and then what do we have? We have a slow pipe and a fast pipe. What about the slow pipe? It can fill one pool in,
X hours.
it's going to be my generic, it's going to be my basic X, so one pool in X hours. Which means, what can the slower pipe do in 1 hour? It can fill 1 over X of a pool. 1x of a pool, if such a thing exists. Then we have the faster pipe. What do we know about the fast pipe?
It's 3 times as fast.
Okay. Fast pipe is 3 times fast. So if the slow pipe is 1 over X, and the fast pipe is 3 times as fast, then that's going to be
3 over X.
3 over X. So it can fill 3 over X of a pool in 1 hour.
Instead of writing 3 times as fast, can we just write 1/3 X hours?
You could. I'm just trying to get the information written down, okay? And basically I'm just trying to take a moment, dissect the problem. What do we know? Because now I'm ready to write the equation. What do we have? We have a slow pipe, we have a fast pipe, and we have what they do together. So, the slow pipe plus the fast pipe equals what they do together. So 1 over X plus 3 over X equals 1 over 12. Okay, what are you doing?
Multiplying by 12X.
Okay, I want my denominators gone. Not as bad as you guys. I don't like working with fractions. I want to get rid of them. So if my denominators are 12 and X, we're going to multiply everything by 12X. And of course 12X as a fraction is 12X over 1. Now, as you guys get better at this, do you need to write it out side by side like what I did on the first one? Not necessarily. But for right now, I'm going to. For the first piece, 12 over X times 1 over X. What cancels?
X.
X cancels, and we're left with
12.
12. Okay, plus. Now I'm going to multiply 12X times 3 over X. What cancels when I multiply 12X times 3 over X?
X.
X is canceled, leaving me with?
48.
Not yet. 12 times 3 is 36. Equals 1 over 12 times 12 over X, or 12X. What cancels? 12s, and we're left with X. 12 plus 36 is
48.
48. So I have X equals 48. So what does X equals 48 tell me? Okay. The slow pipe will take 48 hours on its own to fill the pool. What about the fast pipe? If the fast pipe is 3 times as fast, it's going to take 1/3 of this time, isn't it? 48 divided by 3 is 16. What did the question ask?
The slow pipe. It takes the slow pipe to do that.
Okay. So actually the fast pipe was extra information, wasn't it? Okay, so slow pipe takes 48 hours. That kind of seems more logical if you're filling a large in-ground pool and you just have one hose going to it. 2 days worth. It's also the slow pipe, so. Okay, so that gives you a little bit more experience solving these equations. These, again, are the basic equations, but we also get a little bit of experience writing the equations. Now, ready to jump into all the solving? Do we have what we need from this page? To the screen. Okay, as you flip to the back, okay, guys, these are the core problems. These are we need to know how to solve them. So we're being asked to find the solutions, and of course check for extraneous solutions. So, thoughts? 1 over x minus 5 plus x over x minus 3 equals 2 over x squared minus 8x plus 15. I'm going to say technically yes, not the direction I'm going to take us. Okay?
Left side denominator, right side denominator.
So let's look at that right side denominator. X squared minus 8x plus 15. What do you know about that denominator? Does it factor? Yeah, just like yesterday when we were adding and subtracting fractions. Before we added and subtracted the fractions, what did I always tell you to do? Factor them so we could get a common denominator. Factor. What do we know about x squared minus 8x plus 15? It's x and x. 5 times 3 is 15. If we want them to add to be negative 8, we're going to make them
Both negative.
both negative. Is this a coincidence that it's the same as the left side denominators?
Probably not.
Definitely not. Okay? So, I am going to similarly ask for a least common denominator. I'm not going to get a least common denominator, but we're not going to get a common denominator, but I want to ask what it is because that's what we're going to multiply by. So, are there any pieces of the denominators that are in common in all 3 fractions? Technically nothing in common in all 3, is there? But are there pieces that are in common?
Yes.
Yeah, what pieces do we have in common?
X minus 5 and x minus 3.
Okay, x minus 5 and x minus 3. Does that take care of all of my pieces? Yeah, we don't have any other leftovers we need to grab. That takes care of all my pieces. That right there, folks, is what we're going to multiply this entire fraction by. That's going to get rid of our entire equation by. It's going to get rid of our fractions, so we actually have an equation that is easy to solve, or easier to solve. So, I'm going to multiply my left side by x minus 5, x minus 3. Of course, that means I'm also going to multiply my right side of the equation by x minus 5, x minus 3. Okay. For the benefit of everybody in here, I'm going to write this out as kind of a step showing you what's happening. Because this x minus 5, x minus 3, it's going to multiply into each fraction, right? And so what I'm going to do is I'm going to rewrite my equation out and kind of space it out and show the multiplication this first time through. So I'm going to leave room out front here. The first thing we're going to do is we're going to multiply to the x, 1 over x minus 5, plus, I'm going to leave a gap in front of this fraction. I'm going to multiply the x over x minus 3, equals, and then I'm going to write my right side. I'll multiply afterwards. It's going to be 2 over, I'm going to use the factored form, x minus 5 times x minus 3. Now, what I'm going to show, each of those 3 pieces is being multiplied by x minus 5, x minus 3. Multiplying by x minus 5, x minus 3. And I'm multiplying this piece by x minus 5, x minus 3. Okay? So what I'm trying to show there, and some of you don't need this visual as much of others, but I think it's a good visual. My original equation, each piece is multiplying by x minus 3, x minus 5. I think will help keep everything straight as we show the cancel. As you get figuring out what we're doing, you won't necessarily need to write this stuff out personally. So, first fraction. What cancels when I multiply against 1 over x minus 5? Okay, x minus 5 cancels with x minus 5. Technically 1s, but I never worry about those. What remains? X minus 3 times 1, which is just
X minus 3.
x minus 3. Okay, plus. Repeat the process. Now I have the fraction x over x minus 3. When I multiply, what cancels? X minus 3 cancels with x minus 3. What remains? X and x minus 5. Did you see that x there? That matters, doesn't it? So I'm going to write this as x parentheses x minus 5. On the right, what cancels? X minus 5 and x minus 3 cancel? Leaving me with what?
2.
2. Okay, folks. It might still look like a scary equation to you, but it's got to look less scary at least. The fractions are gone. Okay. What do you think we do next? I'm going to head that direction. I'm going to take a step first. What about this x minus 5? What do you technically need to do here? Distribute. Okay. So I'm going to have x minus 3 plus x times x is
X squared.
squared. Minus 5 times x is minus 5x equals 2. Now, what I see is there's an x squared. I see some x's, and I see some numbers. Are you with me? If I see x squared, x's, and numbers, I'm probably going to want to make this equation equal to 0, and also clean it up as I go. So, on the left, we have x squared. Agreed? What do we have in the way of x's?
-5, x,
So what is x minus 5x? Minus 4x? Now, how talented are you? Can we go ahead and move the 2 in this step? Because this 2 is on the wrong side of the equal sign, isn't it? How do I move that 2 over?
By subtracting it.
Okay, we're going to subtract it. What am I going to end up subtracting the 2 from? The other constant, the minus 3. What is minus 3 minus 2? Minus 5. So now I have x squared minus 4x minus 5 equals 0. Okay, guys. Act like we've been doing this all year. What do I do to solve? We're going to factor. X squared breaks into x and x. I need my numbers that are going to multiply to be negative 5.
And negative 4.
And add to be negative 4. There we go. Negative 5, positive 1. After you get it factored, what do? Set each factor equal to 0. So x minus 5 equals 0. X plus 1 equals 0. If x minus 5 equals 0, then we know we're going to have an answer of x equals 5. If x plus 1 equals 0,
X equals negative 0. Negative 1.
x equals negative 1. So I end up with solutions of 5 and negative 1. What? Why can't 5 be it? Okay. Last step, check for extraneous solutions. Would 5 or negative 1 ever make my denominators equal to 0? Well, right there, that would be a problem right there, wouldn't it? 5 minus 5, I would have a 0 in the denominator. So guess what? 5 is a no-go. Is negative 1 okay? Yeah. My other problem answer would be if we had happened to get a 3. Then I'd have a problem. But negative 1 is okay. It does not make my denominator equal to 0. So that whole restrictions on the variables that we spent a lot of time doing, they keep coming back at us, okay? Okay. Let's go ahead and try B. B has a different type of least common denominator. What do you notice about common denominator there in B? Well, okay, first I guess I should ask, does anything factor? I've got x minus 3, 4. Okay, common denominator. What's in common? There's an x minus 3 in common, yes? That's all that's in common. Any leftovers?
4.
There's a 4. So my least common denominator is 4 times x minus 3. They were nice on this one. They didn't make us factor anything, did they? Now, what am I going to do with that 4 and x minus 3? I'm going to multiply both sides of the equation by
4x minus 3.
the 4 times x minus 3. Now, if you think you can cancel as you go and keep everything straight, awesome. I'm going to write it out just to be safe. So I'm going to leave some space in front. We're going to have 3 over x minus 3 equals. And then I'm going to leave some space in front. X over x minus 3 minus, I'm going to leave some space in front of each of these fractions, x over 4. Because what am I multiplying each fraction by? The 4 and x minus 3. So every term gets multiplied by 4 times x minus 3. 4 times x minus 3. And 4 times x minus 3. Okay? Now, I don't know, are you ahead of me? Have you canceled some stuff? What cancels? X minus 3 cancels with x minus 3 on the first fraction. What remains? 4 times 3, which is 12. Okay, on the right, what cancels in this first set of fractions on the right? X minus 3 cancels with x minus 3, leaving me with what?
4x.
4 times x, which is indeed 4x. Notice what type of problem is this? Minus. It's a minus. What cancels now? 4 cancels with 4. And I've got a x minus 3 and an x. I'm going to write it as x times x minus 3. Okay, guys. From here on out, this problem's going to be similar to the last one. You see parentheses, so you know you're going to have to distribute. Think of this as a minus x as you distribute. Minus x times x is going to be minus x squared. Minus x times minus 3 is going to be plus 3x. What do you see on the right? 4x and 3x are like terms. So I'm going to have a negative x squared. And what's 4x plus 3x? a plus 7x. What are we going to want to do with this equation?
Multiply by negative.
Okay. Generally speaking, we're going to make the equation equal to
0.
0, yes? Now, Savannah's saying multiply it by a negative because she wants negative x squared to be positive. Is that an option? It most certainly is. If we do that, and I guess I probably should have moved that first, but we're going to have negative 12 equals positive x squared minus 7x. To make it equal to 0, we're going to add 12. X squared minus 7x plus 12. Does it factor? Of course. X squared is x and x. Multiplying to be 12 is going to be 4 and 3. Adding to be negative 7. They are both negative. Real quick, hold on. Don't move. Set x minus 4 equal to 0. X minus 3 equal to 0. What solutions do I get?
Positive 4 and 3.
Positive 4 and 3. Are they both good solutions? What's not good?
3.
X minus 3 says 3 is no good. Is 4 good?
Yes.
4 is good. I don't have an x minus 4 up there. 4 is good. Okay, we'll finish notes tomorrow. Make sure you guys go back in and get 4.4 done if you haven't. And thank you for sticking around so nicely. I appreciate it.